So first of all, it's great to be here in Cumbernauld country. Pay my respects to traditional custodians here. I am from Wajak Noongar, so over in Perth, Western Australia. I work for the Minderoo Foundation. So I will quickly give a run through. I'm going to be talking about eDNA and how we use that with IUCN, but I'll give a quick rundown of our organisation first, just in case some of you haven't heard of it. We're actually Australia's biggest philanthropy, set up by Andrew Nicola Forrest in 2001. We focus on sort of key strategic areas being gender equality, uplifting communities, or the team that I'm part of is natural ecosystems, where we're trying to dive in and sort of tackle some of the grand challenges that face our ecosystems, as we've been hearing about today. And so in the natural ecosystems team, we are aiming to ensure we have healthy ecosystems safeguarded for all generations moving forward. So what exactly does that mean? Well, we work in some key areas to facilitate that. We've got a climate action team that's working really in the climate advocacy space, trying to win hearts and minds towards a real zero future. We've got teams working in areas such as marine protected areas, pushing towards 30 by 30, the effective management of those areas so they're not paper parks. We've got teams working up in the Ningaloo coast, the World Heritage Area there, Sustainable Fisheries too, or the team that I'm part of called Ecosystem Intelligence. If you want to talk to me or my colleague Kate Quigley, who's here as well, about any of that, I'm happy to dive into any of those topics. But the one I'm going to jump into today is called Ecosystem Intelligence, and that's really trying to develop new ways in which we can listen and engage with nature. For us, that's mainly in the environmental DNA space, and that's how we think we can actually listen to nature at scale, which is really important. So we all know that measuring biodiversity is critical. I'm preaching to the choir here, but it's really hard as well. So I cut my research teeth in the ocean. I'm a marine biologist by trade, and I done my PhD in a place called Shark Bay, Malgana country in Western Australia, a World Heritage Site over there as well. It's about this, I say bay, it's about the size of Belize, just to put it in context. And in terms of the people power to measure and monitor biodiversity in that area, you have 3 parks and wildlife rangers and 2 fisheries officers. So there's a scale problem there for tracking biodiversity. And when you blow it into the oceans and consider different depths, that scale problem just gets bigger and bigger. And there's costs and barriers to actually tracking that biodiversity, which leads to limited data and limited ability to make strong evidence-based decisions. We've seen this figure as well. We obviously want to get to the point where we're not just arresting decline, but we're actually pushing positive trajectories of biodiversity. But of course, how do we do that? We need to measure and monitor biodiversity as well. And that's where we think that eDNA can partly help fill this gap. So it won't be the solution by itself. That's not the takeaway today. But linking it up with other ways to measure and monitor biodiversity and environmental conditions, we think there's a really critical gap that we can address there. So within the program that I work in, we've got teams working in different areas, all the way through from developing reference genomes that help make environmental DNA assessments stronger and more robust, through to teams that work on empowering and scaling this technology, because that's one of the great things about eDNA. It can be collected using very low-tech solutions, all the way through to high-tech automated samplers, and that'll really facilitate that at-scale collection. We've got teams working to try and get more information from that eDNA data. Oh, the battery is low on the computer. Hopefully I'm really against the clock now. So yeah, that's just getting more information from those samples, moving beyond just presence-absence. And then the area that I work at is really looking at how do we push the data that we generate further? How do we actually facilitate on-the-ground decision-making through eDNA data being collected? And that's where we really see that sometimes with policy, I think quite rightly, it can lag behind some of the scientific advances in the field before it's reflected in policy. And so we're trying to push that area a little bit more, but also looking at new and innovative techniques to try and understand how we can push eDNA data further using approaches like AI. So that led us to collaborate with IUCN. Obviously, they produce one of the most widely used conservation tools in the world in the Red List of Threatened Species. And we've seen a massive opportunity to try and help them embed eDNA into that Red List process. And that was something that they were very keen to engage with. And so really this whole project is to try and and help eDNA data come into the Red List process, but not in a way that's actually going to burden assessors and reviewers. We already know that community is stretched really, really thin, and it's really people's passion that keeps that going. So we've had a couple of different activities within this project. The first was actually at the Environmental DNA conference in February, where we took some of the key IUCN people involved with the Red List over to that eDNA conference and held a workshop where they could chat to some of the leading eDNA scientists in this geographical area, and sort of coming up with some recommendations about how this could go in the future. We're also, from that workshop, internally, we're developing an automated set of tools that allow the assessors, when they're looking at a particular species to examine, that they are able to actually look for that species. How reliable is the biodiversity data in that particular area? So that is on a bit of a roadmap to an actual Red List assessment that's happening for 600 Australian and New Zealand fish species next month in Perth. So we're going to be bringing a lot of fish biologists to the table. We're going to be completing the marine fish assessment for this biogeographical area. So it's kind of a big milestone in the Red List, and that'll be done in August. And then what I'm just back from, so apologies for a bit of jet lag, I've just come back from the UK where we had a technical scoping workshop. So obviously eDNA is just one of many new tools and technologies that's coming through. And IUCN held this workshop as part of this project to sort of identify where are the technical gaps and challenges, where are the bottlenecks, where are the opportunities for really improving the Red List moving forward to make it a more effective and efficient system and not to burden that assessor and reviewer community quite so much. So at this workshop, we had people all throughout IUCN, from the assessment community, from the scientific division. Chief Scientist at IUCN was there. John Paul, the chair of the SSC, was there as well, plus all the Red List partners, and then some people in the emerging technology space. So some eDNA people, some people in the AI community, MIT, Google, that kind of thing. It was kind of a meeting of minds for 3 days. So from that workshop, we're really going to chart a course for what are the opportunities to actually push the Red List forward in this space, all the way from the data input stage. So can we develop automated methods for a system that goes out and scrapes data at large from the internet and pulls that down to the assessors to save them time, all human validated, of course, all the way through to the modeling components of that. Can we better automatically model threats for certain species at the back end so that we can prioritize the assessment and reassessment part of the process all the way through? I did my key recommendation slide. This is kind of specific to this area. I wouldn't say these are my key recommendations for conservation at large, but definitely in the context of this. So I think we do need to embrace new ways to collect biodiversity data at scale. That's just something that we're going to have to do because, unfortunately, it's a massive problem and a massive area. We want to clearly link the data that we collect through to the action and the impact of that data on the ground. So really have these impact pathways fully charted out and understand how we can translate that data more effectively. Anything we design in this area should be focused around what users need. So with the IUCN context, that really has to focus initially on the assessors and the reviewers. We do not want to be adding things in that burden and increase workload. This should make life easier for people, hopefully. Be really inclusive about who can use and reuse data. One of the things I love about eDNA is that when you take a meta-barcoding approach, you get this whole tree of life data that you collect. You might be going out and targeting one or two individual taxa or species, but in collecting this data, it gives you a massive amount of data around the whole tree of life that can be reused by other people later on, like the Red List. And ideally, through all these approaches, we can begin to try and remove our geographical and taxonomic biases through this data reuse component as well. So, yeah, that's me.